Okay, the lab you're going to do tomorrow, I want you to start today because it's a little confusing if you don't know about this compound we're going to use tomorrow, copper 2 sulfate. You have a little hard time getting the molar mass. You just did a whole bunch of molar masses. I did a couple on the board. You did 10 for homework. Okay, probably most of them are done if you worked on it, which means if you're Emily, none of them are done. But we all know Josh and Jared have them all done.
I don't.
No, Jared.
I'm like halfway done.
I'm almost done.
Take a look at this stuff.
I don't write
I had
fast.
2
You guys
left.
were talking.
Yeah, they were talking.
I had 2 left.
Okay. They can actually work, and they can chew and walk gum at the same time.
I can chew and walk gum.
That was funny.
Yeah, he did that before.
Can they hear us on this tele thing?
Did he?
Not usually. They can only hear me. All right. Take a look at this stuff. This is copper 2 sulfate. We're going to use this tomorrow, and our job is, I think I mentioned this earlier, our job is to suck the copper out of it. Not with a straw.
Darn.
Now, you see, copper 2 sulfate, if you were to write the formula for copper 2 sulfate, what would you write down? All right, you'd probably write this.
Copper, Cu.
You'd write Cu.
Yep. Cu. What's
That's a CU.
Different Cu. Okay. I would write Cu.
Hilarious.
Cu, right?
Shush.
And then what?
SO4.
Sulfate, SO4.
SO4 would be SO4.
And it has a -2 charge.
Yeah, and the copper has, since it's copper 2, a plus 2. So that's what you would probably write. And of course, I even wrote it in blue, see, because it's blue.
Oh my god.
But
Why is it blue?
it would be wrong.
Ironic.
It would be wrong. Copper sulfate is not that. That is the formula for the compound CuSO4, and I can actually have copper sulfate that doesn't have water in it. I have some in the back, and it wouldn't be blue, by the way. But this stuff here, all right, actually has water in it. It doesn't look wet. It's completely dry, like a powder, all right? But there's water trapped in there. Actual formula for, you don't write this down. You're going to need it later. The actual formula for water, oops, there should be a 5, is this. Okay, it actually has 5 water molecules intimately bound within its structure. It looks like this. CuSO4, and there's a little, it's not an asterisk, it's just a dot, 5H2O. Okay, so it's called a hydrate. Hydrate, you think of hydration, you think of water. This stuff has water trapped in its crystalline structure, and you can't get it out by just, you know, having it sit around. You could get it out by heating it. We actually do this in a lab for barium chloride hydrate. On Friday, we'll be doing that lab probably for you guys. But tomorrow, that makes a problem for us. When you're weighing this, you're not just weighing the CuSO4. Get that light off for me. You're not just weighing the CuSO4. You're weighing the water as well. Okay? So the molar mass of this guy has to include those 5 water molecules, and that's what I need you to do now before we get back there tomorrow, because we waste too much time. You only have a single period tomorrow. All right, so you're going to have to do the whole lab portion, so you better have this done first. So let me show you how you're going to do it. Take a look at calculation number 1 down there. It says percentage of copper in copper sulfate pentahydrate. And by the way, you also notice the name pentahydrate makes sense to you, right? Penta, 5 hydrates. If it were 2 H2O, what do you think it would be called? Dihydrate. Okay. All right, so.
Aw, can I say hi?
No. I can't have you on here. Go away. Go. It's illegal.
Is it really?
I don't know. I just made that up. But probably is. All right. So I want you to get the molar mass in that space I provided there. And how you're going to do it, I want to show you here. Okay, watch. It's not going to be just 1 copper, 1 sulfur, and 4 oxygens. You're going to also have to include how many waters? How many H's, for example? 10. 5 times 2 is 10. And how many more O's? 5 more. So when you set your thing up like this, which I want you to set up right now, and then do in the next like 5 or 10 minutes, before you have to get this, you have to do, Emily, before you leave here, because it has to be done before you'll never get finished tomorrow. You won't have time to do this and the lab. All right. We've got a copper atom, we've got a sulfur, and we've got an oxygen, right? But then you also have water. Now you need to add all of those guys up. All of them. All right. Now I know oxygen's in more than one place, and you could have added them together. But you'd have how many, if you're doing it this way, you have how many oxygens for the copper sulfate? 4. And how many would you have for the water? Careful now. 5. 5 times 1 is 5. How many H's would you have? 10. Okay, 5 times 2 is 10. So this is what I need you to do right now. Now hold on, before you get it, before you start. What's the point of this? What is that question? What does calculation number 1 ask you to get?
Copper.
Yeah, I got to get the percentage of copper. So you know what you just did in your homework? It's exactly what you're going to have to do here, only you do not need to solve for copper and sulfur and oxygen. You don't. You only have to solve for which one? Copper, right? That's the only guy you need to do it for. So you'll take whatever the total mass of copper is, and you'll do what with it? What will you do with the total mass of copper? To get the percentage of copper. Divide it by whatever your molar mass is down here, right? Right? And show me that work for all of that in that space. For both, this chart and then the percent calculation, but only for copper. I don't need you to do it for everybody.